All right, hello students. So this is a very important Desmos activity here conceptually to understand what it means to balance, understand what it means to be a solution. So right here on the first slide, I made up a random number for x, and we're given it as a picture. When you look at the hanger, we're given it as an equation. I made up a random number for x. We'll call it 2. And then I followed what the equation says. 2 times x plus 3. Well, 2 times 2 is 4. 4 plus 3 is 7. So I have a solution of 2 comma 7. There's no limit to how many solutions I come up with. 2 comma 7 is one of them, but if I want to try another solution, I just make up another x value. Let's try 5. I go 2 times 5, so that's 10, plus 3 more, that's 13, and I found another solution. I got my good little check mark right there, so I know that 5 comma 13 is also a solution. Every number that you want to try as an x has a y value that works with it. There's an infinite number of solutions, and each of the solutions has 2 letters, has 2 numbers, one number for each letter. And that's because we can think of these solutions as points that are on the graph. Now, if you look at the next slide here, you'll notice that all of these points, you can even click on them, are x comma y values that have 2 times the x plus 3 equal the y. And they all make a perfectly straight line. And there's an unlimited number of dots. There's infinitely many dots in either direction, and there's in fact infinitely many dots in between any 2 other dots. So there's an infinite number of solutions when you have one equation. When you have one hanger, there's an infinite number of ways to balance it. Same idea here, even though the x and the y are both on the left side, we still just want 2 times x plus y to equal 15. The way I've shown you to handle these standard form equations is to imagine x is equal to 0. If you imagine x is equal to 0, well, y has to equal 15. And that's true because 2x plus y has to equal 15. 2 times 0 plus 15 equals 15. If I try that dot, it is indeed a solution. Now let's do another one. If I try to put that dot down here, let's just try a place like that. Well, that was too heavy. It's not a solution. The next place I'm going to go is playing the same game. Imagine y is equal to 0. Then we just have 2x equals 15. If 2x equals 15, x needs to be 7.5. 2 times 7.5 is 15. When I try that out, it becomes a solution. What I can do now, it's a little bit hard on the computer screen, but when you've got a ruler and a nice piece of graph paper, you can just connect your dots with a straight line. And in fact, any other dot along that line will also be a solution. So let's try it. Let's put another dot, like right here, 5, 5. Looks like a solution. It looks like it's on the line. And in fact, 2 times 5 plus 5 more is indeed 15. Hope I've convinced you that every point along the line is a solution. And now we get to the really big idea. Can you balance just hanger A? Sure. Any point on the red line will balance hanger A. I just need to drop that point on the red line. It's being a little annoying. There we go. And it will balance just hanger A. It won't balance hanger B because it's not on the purple line. Similarly, if I put the dot on the intersection, that's the solution to the system because it's on both lines. So if it's on both lines, it's the solution to both equations. That's what we mean when we say the solution to the system. Is it possible to balance both? Yes. Is it possible to balance neither? Absolutely. Put the dot somewhere that doesn't touch either of the lines and neither balance. Neither hanger will balance. Now it asks me here, is another point also, this is the same system as from over here, and it talks about this point right there, 3 comma 9 being the solution. Is 2, 7 also a solution? No, it's not on both of the graphs. If I look at 2 comma 7, it's right there. 2 comma 7 is a solution to hanger A. It's a solution to the red line. It is not a solution to the system. That's the big idea of this whole activity right here. Now, when you're going about actually solving, that's when you want to use substitution, or you can use tables, or you can use graphs. I think that the graph is probably the easiest way to do it because it gives you this nice little intersection point that you can click on. And so we can see the solution to the system is right there. So thanks for watching. Please ask questions if something in this video didn't make sense, and I'll make more.